Hi there, I'm Justin Pritchard, and in this video, I'm going to show you how to calculate exactly how long you can idle your engine for on whatever amount of fuel happens to be remaining in its gas tank. And with winter here, well, that might be useful to know if you're, say, stranded or otherwise stuck and waiting a while for help to arrive. Because after all, if you're driving in extreme weather, maybe somewhere dark or remote, it's possible to find yourself stuck off the road or otherwise in a position where you're not going anywhere for a while until help shows up. It's happened to me, it can happen to you or anyone else, and in that situation, it might be useful to know how long you can idle on whatever amount of gas you have left in your tank, because this might be the only way that you're going to be staying warm and maybe even alive. Alright, so not the sort of math that you hope you'll ever need to use, but it's useful to know nonetheless. And by the end of this, you'll be able to look at the fuel gauge in your vehicle, and rather than see the full mark, you'll instead be able to visualize the total number of hours that your specific vehicle can idle for on a full tank of gas. And to get there, you just need to know three things and make two calculations. Very simple math, very, very easy, I promise. In fact, I was surprised because when I was doing the research on how we were going to figure this out, I thought the math was going to be like... But actually, it's really simple. So let's get into it. All right, so the first thing that you need to know is your engine's displacement in liters, and you might know that off the top of your head, and if not, you can Google search it. It might be in your owner's manual, or pop the hood in your specific car or truck and look. Sometimes that's printed right on top of the engine, 5.7 liters, 2.5 liters, whatever the case may be. And the second thing you need to know is the fuel tank capacity of your specific vehicle in liters. How many liters of gas can that fuel tank hold when it's full? And if you don't happen to know that off the top of your head, it's probably in your owner's manual or just a quick Google search away. And the third thing you need to know is a very simple and easy number, and that number is 0.6. Very important, you might want to write that down. And that figure, 0.6, is the number of liters per hour that your engine burns while it's idling per liter of engine displacement. So let me show you how that works. We'll use the Subaru Ascent that you saw in the intro as our example, and that has a 2.4 liter engine, meaning that while idling, it uses 2.4 liters displacement times 0.6 equals 1.4 liters per hour while it's idling. And so another example, maybe you've got one of these. This is the Ford Explorer, and in this particular case with the 3.5 liter V6 engine, and every hour of idling in this machine uses 3.5 liter engine times 0.6 equals 2.1 liters per hour while idling. And let's do an even bigger engine, and since we're on crossovers, let's do the Durango SRT8, and that has a 6.4 liter V8 engine, which will use 6.4 liters times 0.6 equals 3.8 liters per hour while idling. And since we're on Dodges, let's go with a pretty extreme example in terms of displacement, and we'll use this Dodge Viper, which I promise you will get stranded in if you're out with it in the winter, and it has an 8.4 liter engine times 0.6 equals 5 liters per hour while it's idling. Or on the other scale, if you've got a Fiesta with the available 1 liter engine, then it uses 1 times 0.6 equals 0.6 liters per hour while idling. Right, so now you can figure out easily how much fuel your vehicle uses while it's idling, and I will note that whether it's turbocharged or supercharged or not, doesn't matter, the number is still the same. And I'm not certain if this math is the same for a diesel engine, and I'm certain that it's probably not for hybrids, so take these calculations as applicable only to modern fuel-injected gasoline engines. And it's just a matter of taking the fuel tank capacity and doing some simple division. So back to that Subaru Ascent from the beginning, and we know that it has a 2.4 liter engine, meaning that it will use 2.4 liter engine times 0.6 equals 1.4 liters of fuel while idling. And we know that it has a 73 liter fuel tank. So that means that 73 liters divided by 1.4 liters per hour equals a total idling time of 52 hours if the fuel tank is full. So that's something like 2 days, and that means that with half a tank you could idle for half of 52 hours, which is 26 hours, meaning a quarter tank would let me idle for half of that, or something like 13 hours. Let's run through another example or two. Chevrolet Camaro, 6.2 liter engine times 0.6 equals 3.7 liters per hour of idling, and it has a 72 liter fuel tank, meaning 72 liters at full divided by 3.7 liters per hour equals about 19 possible hours of idling on a full tank of gas. And that means about 9.5 hours of idling on half a tank and a bit less than 5 hours of idling if you've only got a quarter of a tank of fuel. And another one, the Hyundai Kona. Hyundai. It's Hyundai like Sunday, that's what they said. That's a 1.6 liter engine, in this case times 0.6 equals 1 liter per hour while idling. And it's got a 50 liter fuel tank, which means that when it's full, it can idle for about 50 hours or about 25 hours on half a tank of fuel, and so on and so forth. And so again, engine displacement in liters times 0.6 equals the number of liters per hour that engine uses while idling. Then you take your fuel tank's maximum capacity, divide it by the number of liters per idling hour the engine will use, and that gives you a total number of hours that you could idle in that particular vehicle on a full tank of gas. And a few final notes. First, hopefully this reinforces the importance of keeping your fuel tank as full as possible in the winter, and especially if you've got something with a bigger engine and a smaller fuel tank. Second, you can save fuel while you're idling if you're stranded by, say, running the engine for 20 or 30 minutes every hour instead of continuously. And third, if you're stuck in the snow, or even if you're not stuck but it's snowing out, be sure to check and clear any snow away from your tailpipes regularly, because if you don't, you are at a dramatically increased likelihood of being killed by your car's exhaust gases, and that would be total BS. Very seriously though, people die every year from exhaust fumes in that situation, so clear the area around your tailpipes and clear it often. Well, that's all I've got for this time. Until next time, take care and drive safe. My name is Justin Pritchard, and we'll see you next time.